I'm Dimple, and today we're going to be talking about Polybius Square ciphers. Before we start, I want to talk real quickly about where the cipher came from. So the Polybius Square was actually created by the ancient Greeks. Specifically, it came by a scholar named Polybius. He got a cipher named after him. How cool is that? The Polybius Square is 5 by 5 and it contains all the letters of the alphabet. Now there is one key difference between the Greeks' version of the cipher and our version. You see, they only had 24 letters in the alphabet, so all the letters fit nicely. In fact, there was one empty box. Here's where things get a little tricky. We have 26 letters, so basically, of all the letters, 2 letters will be sharing a box. Those 2 letters happen to be I and J. Now let's take a look at the actual Polybius Square to get a better idea of what this all means. As you can see, the I and J both share the position 2, 4. The rest of the letters have their own box. So how do we use the square to encode and decode a message? Well, it's pretty simple. Each letter corresponds to 2 numbers. The way we read the square is from row to column. A is 1, 1, B is 1, 2, and so on. Now that we know how to read the Polybius Square, let's try to encrypt a message. Let's say your word is science. Find S in the square, then look to the left. What number row is it in? It's at 4, so let's write that down. Now go back to the S and look up. What column is it in? It is in the 3rd column, so let's write that down. 4, 3 is the first 2 numbers of the code. Now let's encode the rest of the word. C is 1, 3, I is 2, 4, E is 1, 5, N is 3, 3, and we already know C is 1, 3 and E is 1, 5. Now let's put that all together. Our encoded message should look like this. 4, 3, 1, 3, 2, 4, 1, 5, 3, 3, 1, 3, 1, 5. Now, say we were to encrypt the word juice. J is 2, 4, U is 4, 5, I is 2, 4, C is 1, 3, and E is 1, 5. So we get 2, 4, 4, 5, 2, 4, 1, 3, 1, 5. And in cases like this one, where J and I are both being used, you can choose to take out either letter and encode the message like J. Either way is fine. You can even code these messages following a column-row basis instead of a row-column. There are different ways to do this, but as long as the receiver knows what the pattern is, the cipher does its job. Now let's look at a different Polybius square. This is an example of a square formed based on a keyword. We would fill up our square left to right with the letters of the keywords. Once we are done with the keyword, go from A to Z for the remaining boxes and make sure no letter is repeated. After you complete this step, our square should look like this. Note that 22 is not E because E is already 11. We don't want any letters to repeat. Okay, now real quick, let's encode the word home. Pause the video and see if you can do it on your own. If you got 32, 41, 14, 11, then you did it. Nice job. If you don't get it, don't worry. There's one more example. Try to decrypt 23412124. Pause the video and try it out. If you got the word cold, C-O-L-D, then you are correct. If you're still struggling with the Polybius Square, I'm sure that with little practice you will get it in no time.